Our next unit, or lesson, 10.5, is going to have two kinds of problems for us. First of all, we're going to revisit regular polygons, but we're going to end up needing to use trigonometry in order to find missing measurements that we need. And then in the second case, we're going to take a look at triangles and find a second different way to find the area of a triangle that involves trigonometry. So part one of this lesson is going to involve using trigonometry to find some missing measurements we need. So maybe to refresh our memory, let's put up that acronym that we used, SOHCAHTOA, to remember our three trig ratios, sine, cosine, and tangent, and what those ratios are. The sine ratio is the opposite side over the hypotenuse. The cosine ratio is the adjacent side over the hypotenuse. And the tangent ratio is the opposite side over the adjacent side. Okay, with that in mind, we're going to go straight to examples. No new formula to learn, just revisiting regular polygons. So what is the area of a regular nonagon? Nonagon is 9 sides. Nonagon. With 10 centimeter sides. Round to the nearest square centimeter. So we've already got a nice picture given to us. If you recall, the area of a regular polygon is half the perimeter times the area. Perimeter times the area. Since we're given the length of a side, we can find the perimeter. The perimeter, each side is 10 centimeters. We have 9 sides, so the perimeter is 10 times 9 centimeters. What we don't have is the apothem. The apothem. That's drawn here in our figure. Here is an apothem. And we form these right triangles that we're going to use again to find that measurement. So, since each side is 10, when we draw the apothem, here it bisects a side into 5 and 5. And then we need to know the measure of this angle up here. To do that, once again, we can imagine drawing all these radii. I'll only draw this many. If I do that, it breaks my nonagon into 9 triangles and 9 congruent angles in the middle here. So if I want to know what one of those angles is, take 360 degrees, a full circle, and divide it evenly by 9. That leaves you with 40 degrees. So any one of those angles is 40 degrees. When we draw the apothem, it bisects that 40 degree angle into 20 and 20. So that's this triangle we're pulling from right here in this picture. That's this triangle. We just pulled it outside the picture to work with. So we have a 20 degree angle. This side is 5. I want to know what this side of my triangle is. Back in section 10.3, we used our special right triangles. When we were working with triangles and hexagons, they created 30, 60, 90 triangles, and we were able to find our missing side using those special ratios. If we don't have one of our special right triangles, we need to resort to trig to find our missing measurement. So if I'm looking from the 20 degree angle, label your sides. Opposite is across from that angle. The adjacent side is the other leg right next to the angle. The hypotenuse is always across from the right angle. The hypotenuse is always across from the right angle. That's your longest side. So the side I know and the side I want to know are the opposite and adjacent sides. So which trig ratio am I going to use? I want to use the tangent. The tangent involves the opposite and the adjacent side. So what we can set up is the tangent of my angle, which is 20 degrees, is equal to the opposite side over the adjacent side, 5 over a. Now, if you recall when I wanted to solve for a variable that was in the bottom of this fraction, what ended up happening is these two pieces traded places, right? We multiply a over, and then we divide by the tangent of 20, and these two guys flip-flop. So bring a over to this side and put the tangent of 20 down in the bottom of your fraction. And that's our apothem, 5 divided by the tangent of 20. We can put that whole thing in for our apothem, and then we just have to calculate. So if I had my calculator, I would do 5 divided by the tangent of 20 first, then multiply by 9, multiply by 10, multiply by 1/2. It said round to the nearest square centimeter. If we're rounding to the nearest centimeter, that means whole number, no decimals. You should get, and try that out on your calculator, 75, and we're dealing in centimeters, so square centimeters. So the formula is the same, 1/2 perimeter times apothem. Sometimes we just need to use trig to find one of those values, or both of those values. So let's look at another example. A stop sign is a regular octagon. Octagon is 8 sides. Octagon, 8 sides. The standard size has a 16.2 inch radius. What is the area of the stop sign to the nearest square inch? So we've got some pieces already labeled in our picture. They drew the radius here for us. I'll bold it a little bit. Remember, the radius of a regular polygon goes from the center to a vertex, one of the corners of our polygon. And what we need to find the area of this regular octagon is the perimeter and the apothem. Now in this case, I don't have a side length, so I can't find the perimeter. I also don't know what the apothem is. So we're going to have to solve for both of those pieces. We're going to draw the same picture in our regular polygon. They've already got a couple important pieces labeled. So if you can't tell, there's an arrow right here saying this angle in here is 22.5 degrees. How did we get 22.5 degrees there? Well, if you imagine, I draw all the radii into my octagon, right? And then I'll just stop there. I have 8 congruent angles in the middle here that form a full circle. So if I want to know what any one of those angles are, take 360, the degrees in a full circle, divide it evenly 8 times, and what you get is 45. Then when I draw the apothem in, that bisects that 45 degree angle. Half of 45 is 22.5. So we're getting that from half of 45. Right? Any one of these angles is 45. If I cut that in half, 22.5. That apothem forms a right angle with the side. So we have this right triangle. In order to find the perimeter, I need to know what the length of a side is. So let's go after the perimeter first. Using my right triangle, I could find the length of this side, which we have labeled x. If I were able to do that, this full side is just twice that length. The apothem bisects the side, cuts it into 2 equal parts. If this side is x, this side is also x. So let's solve for x. We can double that, and then multiply that by the number of sides we have to find our perimeter. Okay, this right triangle, once again, since we're in the unit on trigonometry, is not one of our special right triangles. So we're going to have to use some trig. If I'm looking from this angle, x is my opposite side across from. A is my adjacent side. And the 16.2 is my hypotenuse across from the right angle. For solving for x first, that's the opposite side. The side I know is the hypotenuse, so which trig ratio do I want to use? which involves the opposite and hypotenuse. That's the sine ratio. I want to use the sine ratio. The sine of my angle, which is 22.5 degrees, is equal to the opposite side, which is x, over the hypotenuse, which is 16.2. In this case, to solve for x, it's on top. All we need to do is multiply by 16.2 on each side. So then x is the sine of 22.5 times 16.2. That's just this part though. That would be this part. If I want to know the perimeter, we need to take that, so 16.2 times the sine of 22.5. That gives me the length of x, but one side of my regular polygon would be double that. So let's multiply that by 2. That would give me the length of one side of my polygon. And since this is an octagon, I have 8 sides. So to find the perimeter, take the length of your one side, multiply it by 8. Now if we go ahead and multiply this all out, we get a perimeter of 99.19, and I'll just round it to 2 decimal places for now. That's our perimeter. We can plug that in, 99.19. And now the only other piece we have to find is the apothem. The apothem over here is A. So we're going to use the same triangle, but in this case, A, what I want to know is the adjacent side, and the side I know again is the hypotenuse. So which trig ratio do I want to use, which involves the adjacent side and the hypotenuse? That is the cosine ratio. So to find the apothem, which is A in our picture, we'll take the cosine of my angle, which is still 22.5. That's equal to the adjacent side, which is A, our apothem, over the hypotenuse. The hypotenuse is 16.2. And to solve for A, our apothem, just one step. We multiply each side by 16.2. So our apothem is the cosine of 22.5 times 16.2. We can just put that in to our formula. That's the apothem, cosine of 22.5 times 16.2. And to find the area, we just have to multiply all of this out. If you multiply all those, we are rounding to the nearest square inch. So whole number, no decimal once again. If you do that, you should get 742. Our measurements were in inches, so the area is inches squared. Inches squared. Right, so you can see it takes a few steps to find the pieces we need to find the area of these regular polygons. Right. So let's do one more example. A tabletop has the shape of a regular decagon. Decagon, 10 sides. Decagon has 10 sides with a radius of 9.5 inches. What is the area of the tabletop to the nearest square inch? So very similar to our last problem, except we don't have anything labeled. So let's put in the pieces we need to know. Here's a decagon for you, 10 sides. A radius of 9.5. So a radius goes from the center, so put a center in to your figure, to one of the vertices. So any vertex on your figure, that's 9.5. That's all we're given. What we need to know is the perimeter and the apothem. Right? The area is 1/2 perimeter times apothem. So let's draw a picture similar to that problem right above. Drawing the apothem, we can call it A. We'll need to know the length of that. And we'll also need to find the perimeter, know the length of a side. So throw an X down here. We can find that measurement, double it to find the length of a side. The last thing we need to know is what the measure of this angle is. So imagine again if I drew in all the radii of my decagon, that would create 10 congruent angles, because decagon is 10 sides. 10 congruent angles in here. If I were to divide 360 degrees evenly by 10, each angle in the middle here is 36 degrees. 36 degrees. So when we draw the apothem in here and we bisect the 36 degree angle, this angle that's left over is 18 degrees in there. Okay, now we have our right triangle. It's not one of our special right triangles, so we're going to have to use trigonometry to find these missing sides. Let's start finding the perimeter again. So we want to know what the side of our decagon is. Let's solve for x first. So in my right triangle, label your sides. If I'm looking from this angle, x is the opposite side across from the angle. A is the adjacent side right next to that angle. And 9.5 is my hypotenuse across from the right angle. That's my hypotenuse. So if I want to find the opposite side, and the side I know is the hypotenuse, the trig ratio I want to use is, once again, the sine. Sine uses the opposite side and the hypotenuse. So we can write the sine of our angle, 18, is equal to the opposite side over the hypotenuse. X over 9.5. And since x is in the numerator, only one step here to solve for x. Multiply by 9.5 on each side, so those would cancel out, and x is 9.5 times the sine of 18. However, if I want the perimeter, not just x is this length, right? Only half of the length of a side. So to find the perimeter, let me take that value, x, which is 9.5 times the sine of 18. That gives me the length of half of a side, so to find the length of the whole side, double it. Multiply by 2. If you double it, that would give you the length of this whole side.